Hello, geometry students. Here's your lesson for section 4 for congruent triangles with Missy McCarthy, Okemos High School math instructor. By the end of this lesson, you should be able to say that I can identify corresponding angles and corresponding sides when given two congruent polygons. We're mostly going to be dealing with triangles, but polygons in general. I can write a congruent statement for congruent polygons. I can use properties of congruent triangles to find missing angles or sides. And I can prove that two triangles are congruent by showing that all of the corresponding angles and all of the corresponding sides are congruent. All right, so congruent figures. We've been using the term congruent for a long time, but only when it comes to segments and angles and such. Now we're going to talk about objects being congruent. So for example, triangles are congruent or rectangles being congruent and so on and so forth. So here it says congruent implies that they are the same size and the same shape. All of the corresponding angles and all of the corresponding sides are in the same position of each of those polygons. And they have equal number of sides. Two polygons are said to be congruent if and only if all of the corresponding angles are congruent to each other and all of the corresponding sides are congruent to each other. You can see from the markings here on these two diagrams which parts are corresponding, A and D, B and E, C and F in terms of the angles, and then you can also see the sides, and because they are all congruent, then those two triangles are congruent. All right, so here's just another diagram of sorts that shows you the corresponding angles and the corresponding sides and how they're congruent. The only thing that this adds is it shows you how to write a congruent statement. So we would say triangle ABC is congruent to triangle DEF. Notice the ordering of the letters. We put corresponding letters together. And likewise here we said polygon PQRS is congruent to polygon WXYZ. Again, notice that the letters match up with their corresponding parts. So let's try an example here. If they give us a congruent statement, can we identify all of the congruent corresponding parts? Well, sure we can. Because triangle PQR is congruent to triangle STU, we know that angle P is congruent to angle S. We also know that angle Q is congruent to angle T, and we know that angle R is congruent to angle W. Likewise, we can do corresponding congruent sides. PQ, the first and the second letter, is congruent to segment ST. The last two letters, segment QR, is congruent to segment TW. And lastly, if we take the first and the last letter, segment PR is congruent to segment SW. So that's how you identify all of the corresponding angles that are congruent and all of the corresponding sides that are congruent in two congruent triangles. All right, so we can use the fact that two triangles are congruent to find missing parts here, okay? So we know that triangle ABC is congruent to triangle DBC. So if we look here, that means that I know that angle ACB is congruent to angle DCB. So therefore, this guy must be a right angle, and I can say that means that 2x minus 16 is equal to 90. Add 16 to both sides, we get 2x is equal to 106. And then divide both sides by 2, and that means that x is equal to 53. So we have found the value for x as it says in part A. In part B, it says find the measure of angle DBC. So DBC, where is that angle? DBC, that's this guy right in here. Well, it's congruent to this angle right in here, all right? So we know that this is 90, we know that that is 49.3, and so we can figure out what this one is using the triangle sum theorem. We can do 180 minus 90 minus 49.3, and that gives us 90 minus 49.3. 90 minus 50 would be 40, so 90 minus 49.3 would be 50.7. Oh, goodness gracious, 40.7. 40.7 degrees. So since that is the measure of this one right here, then that means that's also the measure of angle DBC. The red one is also 40.7 degrees. Okay, that's in the way here, but we're to prove that two triangles are congruent, we need to show that all of the corresponding sides and all of the corresponding angles are congruent, because that's what the definition of congruent figures is. So now we're going to walk through how you would prove that two triangles are congruent. Okay, so first let me put statements here and reasons here, and I'm going to fairly warn you these proofs can get long, because we need to prove that 6 different angles are congruent, and we also need to prove that 3 different pairs of angles are congruent and 3 different pairs of sides are congruent. The nice thing about these kinds of proofs is that they give you lots of given statements to work with. So 1, I'm going to start with the fact that angle WYX and angle oh my goodness, I'm saying the wrong letters. Let me say that again. I'm going to start with the fact that angle YWX and angle YWZ are right angles. That's my first given statement. They are right angles, and that is given to us. So because they're both right angles, by definition of, by the right angle congruence theorem, we can say that means that angle YWX is congruent to angle YWZ, and that is the right angle congruence theorem. Okay, so that's one pair of congruent angles. Now I'm going to go to the second given statement that they give us. They say that segment YW bisects angle XYZ. So that's given to us. Go to your diagram and make sure you understand what that means. YW bisects angle XYZ, and that makes for 2 congruent angles right there. So we can say that means that angle XYW is congruent to angle ZYW, and that is by definition of an angle bisector. Definition of angle bisector. All right, we are 1/3 of the way there. We've gotten 2 pairs of corresponding parts. We need a total of 6. So now I'm just going to say, at the end of that, if these guys are congruent and those guys are congruent, then that means that angle X is congruent to angle Z by a theorem you just recently learned called the third angles theorem. So we've now got 3 pairs of congruent angles. Now we need 3 pairs of congruent sides. Let's go back to our givens. 6. We know that W is the midpoint of segment XZ. That is given. Now I've got to continue this proof over here. Sorry about that. So W is the midpoint of segment XZ, so that means those 2 are congruent. So step 7, that means that XW is congruent to WZ, and our reasoning is definition of midpoint. Right? All right, so then 8, what can we say next? Ooh, we see that WY is congruent to itself. Okay, so that's another pair of congruent sides, and that is by the reflexive property of congruence. All right, and then the last given, thank goodness, tells us that we know that XY is congruent to YZ. That was given to us. And so now we've got 3 pairs of congruent segments. So then we can say that means what we're trying to prove is that triangle XYW is congruent to triangle ZYW by what we call definition of congruent figures or congruent polygons. Long, long, long proof. All right, I was planning to do another one, but I think we'll just start class with this one tomorrow. I would encourage you to try this proof on your own. Okay, I'll see you then.